So today I will try to show that what Heisenberg did in 1925 with the introduction of matrix mechanics to deal with the electron dynamics within atom can be interpreted in an ontological sense. As an ontological a new way to say what the electron actually is. And to show this, I will adopt a phenomenological approach, an approach based on Husserlian phenomenology, mainly. So, first of all, I will spend a very few words on all the quantum theory, in particular on the ontological problems of the Bohr-Sommerfeld atom. Then I will present some elements of the introduction of Heisenberg's matrix mechanics in 1925. Then I will present the phenomenological perspective I will apply to this approach, and will show how this phenomenological perspective enables us to interpret Heisenberg's move in an ontological way. So I will talk basically about ontology, but in a bit different way from what Greg did before. So all quantum theory is in large part a theory of atomic radiation, as you know, and the underlying model of the atom which was used is the Bohr-Sommerfeld atom. This was very useful in characterizing some aspects of atomic radiation, but at the same time was unsatisfactory for what concerns the characterization of phenomena like the anomalous Zeeman effect, the relative intensity of emission lines, and the fine structure of spectral emission lines. But what we are interested more here is the fact that it gave us a contradictory ontology for the atomic electron. In which sense? In the sense that here the depiction of the atom was characterized by the idea that there were electrons interpreted as classical corpuscles moving along classical orbits around a central nucleus, and the atomic radiation was interpreted in terms of jumps from one orbit, which is on an energy level within the atom, to another one. Why this was ontologically contradictory? Because such a configuration is mechanically unstable. So we were in the weird situation where the electron at the same time was considered a classical corpuscle, but at the same time had to violate the laws of classical mechanics and electrodynamics. This picture, this model gave us a contradictory picture about what the electron actually is. These ontological concerns were very well present to Bohr himself, and even if initially he presented this model as a realistic depiction of what the atom was, after basically 1920, he recognized that it had to be interpreted in a heuristical and metaphorical way. We can see in these ontological concerns, at least in part, one of the reasons behind the development of the concept of complementarity by Bohr, especially for what concerns its part concerning the wave-particle duality, as a concept that Bohr introduced to deal with contradictory aspects in the behavior of electrons and photons. First of all, without ending up in contradictory ontologies like the one I presented in reference to the Bohr-Sommerfeld. But the most interesting move here is the introduction of the new quantum theory developed by Heisenberg in 1925 in the form of his matrix mechanics. This move has been seen as a form of de-ontologization of the model of atom. What do I mean with this? Well, basically, every representational model carries with it a certain ontology. And even if we admit that a model had to be interpreted only metaphorically, it is still a matter of fact that it carries with it a definite ontology. So what Heisenberg did was to renounce to any representational model, to any visual characterization of the electron dynamics within the atom, and in this way he developed a theory that no longer contained, apparently, an explicit ontological commitment on the structure of atom. However, I claim that precisely through this move, what Heisenberg did was to introduce a new way to define the objecthood of the atomic electron, a new way to introduce electrons ontology. To understand this, first of all, we have to notice that Heisenberg never renounced to the concept of electron. What he did was to claim that we can no longer talk about electrons in terms of classical orbits, but we can characterize it through the atomic radiation. We can characterize its behavior through atomic radiation. And what he did was actually a reconceptualization of the electron, namely a reconceptualization of its kinematic properties. So let's give a very sketchy presentation of some fundamental elements in the introduction of matrix mechanics as presented by Heisenberg in 1925. Heisenberg's starting idea was that we cannot characterize electrons in terms of classical concepts, orbits, and corpuscles, first of all, but we can characterize it, as I said, in terms of the radiation atomic electrons. The second idea I started from was that to solve the problem of constructing the electrons dynamics within the atom, we need to solve a certain equation of motion, some kind of equation of motion. He did so for a toy model, the anharmonic oscillator, but here I will make reference directly to the hydrogen atom because this model was applied 1 year later directly to the hydrogen atom by Paul. So, Heisenberg started from the observation that classically to solve this kind of equation of motions, we can apply a Fourier expansion to quantities like position and momentum, which were the quantities that in the semi-classical Bohr-Sommerfeld model were used to characterize the electrons orbit. In particular, he associated to the coefficients in the terms of this Fourier expansion the amplitudes, which basically means the intensities, and the frequencies of the spectral lines observed in the radiation emitted by the hydrogen atom. Then he noticed that with such an association, it was no longer actually possible to talk about literal Fourier expansion, but we still could associate to the position and the momentum, to these two quantities, certain sets of quantities which corresponded to the Fourier terms in the classical case, which are the quantum correspondent of the Fourier terms in the classical case. So at this point, what Heisenberg needed was to know how are the set of quantities associated to quantities like x to the second power, x to the third power, and to the product x times p, once we know what is the set of quantities associated to x and p. So he developed these relations, which were recognized later by Born as instances of matrix multiplication rules, and in particular, from this it follows that in the case we consider the product between x and p, this is no longer commutative. It is expressed by the famous commutation rules through which Heisenberg introduced his quantum condition, his quantization condition. So what we have is that this set of quantities that corresponds in the quantum case to x and p, position and momentum, are now to be considered matrices. They are matrices that can no longer be used to define a classical orbit. And each of these elements, each of the elements within these matrices correspond to a certain transition between atomic energy levels, and is characterized through the coefficients that appear within it. It's associated to the amplitude and to the frequency of the corresponding spectral lines. These coefficients are linked one with the other through a set of recurrence equations. So we have a scheme that correctly characterizes the relation between intensities and frequencies for the spectral lines of the hydrogen atom, and gives us a coherent energy, a coherent structure for the atomic energy level, coherent with the previous results obtained by Kramers in his light dispersion theory, and coherent with the Kramers-Born procedure. So what we have at this point, we have seen that x and p can be substituted with matrices. We have now a purely algebraic scheme plus some interpretation rules that accounts in a consistent way for the relation between frequencies and intensities of spectral line, and provides us a coherent picture of the energy level of the hydrogen atom. We have a consistent algebraic picture that directly connects all the observable quantities associated with the atomic electron without the need to resort to any classical concept like orbits or corpuscles. So, in which sense does this picture provide a new ontology for the atomic electron? Well, I claim indeed that this framework, this algebraic, this theoretical framework, tells us in some way what is the essence of being an electron. But to understand this, we have to show that the characterization of atomic electrons dynamics in terms of matrix mechanics can be seen from a phenomenological point of view as a process of intentional constitution, as it said. That is the process through which a certain object manifests to an observer as a certain type of entity, that is, with a certain ontology. In particular, to do this, I will adopt the phenomenological perspective, a modified version of the phenomenological perspective introduced by Shannon Valor in 2009. So I don't know how familiar you are with phenomenology. I cannot explain here a lot of details of what phenomenology is. I will just say that it's a philosophical perspective developed by Husserl in the first decades of the 20th century, which presents itself as a form of scientific philosophy of the structures of experience, focused in particular on the correlation between an experiencing subject and the experienced world. Why is phenomenology interesting in this kind of perspective? Well, first of all, because it offers us a set of tools to study the structures of experience from which the world, therefore the different objects we experience with their different ontologies, emerge. The fundamental phenomenological question is what are the experimental processes at the basis of our positing of certain entities, of certain types of entities in the world. We have indeed, from a phenomenological point of view, different kinds of entities characterized by different ontologies, which at last, for what concerns phenomenology, means characterized by different ways of manifesting to a certain observer. Different ways, different structures of experience associated to their manifestation. For example, we have physical objects like tables, which manifest in a certain way with certain structure of experience. We have different entities like rainbows, reflections, mirages, which manifest in a different way with different structures of experience. And then we have more exotic entities like, for example, abstract objects like complex numbers, for example. So at this point, we may ask ourselves, what about the so-called unobservables of science? So what are, first of all, unobservables of science? This is a very complicated problem, but we can define them as every entity postulated by scientific theories that cannot be directly perceived with unaided human senses. I think we could agree that electrons fit quite well within this definition. What Valor did in her 2009 paper was precisely to tackle the problem of the reality and object of this kind of entities, and basically she came up with the claim that the way through which entities like elementary particles are introduced in scientific discourse can be seen as a process of intentional constitution, in particular analog to the intentional constitution of ordinary perceptual objects like chairs and tables, as presented by Husserl, in the sense that the structures of experience associated to these two different kinds of objects are the same in both cases. So to understand her approach, we must know something of the Husserlian theory of the intentional constitution of perceptual objects. That is the theory that tells us how perceptual objects emerge from certain structures of experience. So let's take a very simple example. Typically here there is a table, but now there is not. I will make believe that there is a table indeed. So let's take this example that I enter this room and there is a table inside. First of all, I get struck by a set of visual sensations, which gives me a certain perspective of the table. As I move around it, the perspectives I see of the table change. And these different perspectives, which manifest in a spatio-temporal continuous way within my field of view as I move around the table, sediment within consciousness, get retained by memory, and gets unified into a unique sequence of perspectives or perceptual profiles, as Husserl says, due to the fact that they manifest in a spatial-temporal continuous way within my field of view, and to the fact that they exhibit certain regularities which I associate to the table. Typically, the fact that the different parts of the table keep their respective geometrical relations with each other, even if the perspectives change according to the laws of perspective. So, from this example, a fundamental aspect of what is intentional constitution of ordinary object emerges, and in particular, what Husserl notices is that from this ordered sequence of perceptual profiles sedimented into consciousness, the observer extrapolates a certain horizon of further possible perspectives that he or she can observe about the table if he or she keeps moving in a certain way around it. So when I perceive an ordinary perceptual object, I not only experience a well-defined individual perspective of it, but to the experience is always associated also this horizon of further possible experiences I can have of this object, a horizon of anticipations concerning these further possible experiences. So this is a fundamental property of the intentional constitution, which is horizonality. Then we have other fundamental properties, which are adumbrativity, which is the fact that at a certain moment I only see actually one single perspective of the object. These different perspectives get synthesized, as I mentioned before, in consciousness. Then we have horizonality that I have already presented. And this horizon of anticipation can be unlimitedly explored by a competent observer. A competent observer knows what actions to take to test whether the backside of the table corresponds or not to his anticipation about So Valor claims that what qualifies something as a perceptual object is this kind of style of manifestation characterized by adumbrativity, horizonality, explorability, and so on, and not observability in the sense of the definition I gave before about unobservables. She notices that phenomenologically what matters in evidentiary considerations is the distinctive style of perceptual presence and not the unmediated display of discrete sensibilia. Rather than asking whether the thing's impact on our unaided senses produces some definite set of qualia, we must ask whether the thing can manifest itself to us in a perceptual style, that is, in a coherent and pregnant manifold or of kinesthetic relations explorable within our spatial-temporal horizon. And she claims that the way elementary particles manifest within the practice of science precisely possesses these characteristics. She takes this case study of the J-psi meson, elementary particle discovered in 1974 as a resonance, which means that it was not directly detected, it was very short-lived, but what was detected were the decay product of this particle. It was allegedly produced by making a high-energy proton beam impact onto a beryllium target, and in the plot we can see here a peak in the number of decay products observed in correspondence to a certain energy for the proton beam, which means that at that energy we had the production of the J-psi. Valor notices that the J psi manifests precisely in this adumbrative, horizontal, and explorable way, and that that scientists interacted with this new entity precisely in the same way a competent observer interact with an ordinary perceptual object, with this kind of explorability I described before. She says, they, referred to the physicists, altered voltage settings, narrowed the data collection aperture, removed the detection chambers, and measured the event yield. No unexpected change in the peak resulted. They increased the target thickness by a factor of 2 to see if the yield increased in the same proportion. It did. In short, the experimenters worked to establish that their detectors had engaged an independent and dynamic structure possessing its own pregnant depth and horizon. Then she makes a parallel with a very familiar perceptual situation. Is that a real insect I feel biting my ankle, or is that tiny pain just a momentary nerve twinge? The efforts of Thing's team, the discoverers, to tie the peak to the functioning of their equipment are not different in kind from the attempts of ordinary perceivers to ascertain the veridicality of their experiences. They know what adjustment to make to hone in on or probe a specific type or facet of an event signature, just as an ordinary perceiver knows precisely what range of motions will allow her to palpate the distinctive profile of a bug on her ankle. She noticed that there are some differences between the ordinary and the unobservable case, but she disregards them as not very significant. In particular, she notices that in the unobservable case of the J psi, we have a lot of mediation represented by the technical apparatus we have to use, represented by the huge amount of calculations scientists had to perform, and so on and so forth. But basically, she claims that mediation is also present in the ordinary perception of ordinary perceptual objects. Simply, it is much more evident in the case of unobservable entities for obvious reasons. So, what Valor concludes is that unobservables like elementary particles, like the J psi meson, for example, are completely analogous to the ordinary perceptual objects when it comes to the way they emerge from experience, when it comes to the structures of experience through which they emerge as objects. So, the process through which entities like the J psi meson are introduced in scientific discourse is completely analog to a process of intentional constitution, in particular to the intentional constitution of ordinary perceptual object. These objects, these unobservables, are therefore at least as real as ordinary perceptual objects like this perspective needs an important integration, which is fundamental for our understanding of how it can be applied to the case of Heisenberg's electron dynamics. In particular, Valor overlooked a crucial difference between the ordinary case and the unobservable case. The difference is in the cognitive instruments that in the two cases are responsible for the synthesis of different perceptual profiles. Let's go back to the case of the table. We have seen that there the different perspectives of the table were unified because they manifested in a spatial-temporal continuous way within the field of view of the observer, and because they presented to the observer certain very specific regularities concerning the table, namely the conservation of the spatial relation between its different parts. This kind of process cannot provide unification to the perceptual profiles on which scientists base the introduction of an object like the J-psi meson. For what are the perceptual profiles in that case? Well, for example, they are plots like the one I showed before, that an experimenter sees on a computer screen in a certain laboratory with a certain experimental setup, and then another one that is seen on another computer screen in another lab with a completely different experimental setting. So we no longer have in this case the spatio-temporal continuity we have in a quite obvious way in the ordinary case of the table. Moreover, the regularities that these profiles on the basis of which physicists introduce objects like the J-psi meson are different from the limited range of regularities that the human mind can capture simply because it has evolved to capture precisely those kind of regularities which are those that enables humans to survive in a standard environment. So, what's particular about this kind of regularities we find in scientific experiences, which are, for example, of the type of this one I plotted here, which is the relation between the cross section for the production of the J-psi meson in function as the proton beam energy. They need to be to be captured, they need the explicit use of mathematical formalism, in the sense that they explicitly need for scientists to write down and solve equations following the rules of an art, the rules of the mathematical techniques they are actually applying in that specific case. So from this, a new role for mathematics emerged in this intentional constitutive picture. And we see that mathematics here plays the role of the cognitive instrument that enables us to put together, to unify into a unique sequence different perceptual profiles that manifest in the practice of science, on the basis of which entities like the J-psi meson are introduced. In this sense, mathematics acts as a prosthesis of the human innate synthesis abilities we have seen at play in the case of the table, enabling us to capture a much larger and virtually unlimited range of regularities, range of arbitrarily complicated relations, and therefore to constitute, in the sense I presented before, an accordingly larger range of object tools, and therefore of ontologies. So, on this basis, we can see that this role of mathematics, the role I just depicted for mathematics here, is precisely the role played by Heisenberg's matrix formalism in the Heisenberg's description of the atomic action dynamics. There, the algebraic formalism unifies into a common theoretical picture a set of empirical manifestations, typically spectra, atomic spectra under different conditions, providing a coherent connection between the associated observables, which we have seen are spectral line frequencies and amplitudes, and capturing the regularities they exhibit. It is this algebraic formalism that enables us to make anticipations concerning the further possible experimental evidences we can have about atomic spectra. So it also plays this fundamental role of enabling us to create this horizon of anticipations concerning further possible frequencies. So phenomenologically, it plays a synthetic role, enabling us to interpret some empirical evidences as manifestations of the atomic electrons. So once we recognize this, we can see that in this sense, the characterization of atomic electron through Heisenberg matrix mechanics can be seen indeed as a process of intentional constitution of the object atomic electron. The atomic electron, as viewed through the lens of matrix mechanics, is an object that emerges from a set of perceptual experiences in the laboratory that share the same experiential structure of ordinary perceptual objects, but with the synthetic function played by the mathematical formalism, by the algebraic formalism of matrix mechanics. So at the beginning, I had claimed that from a phenomenological point of view, the process of intentional constitution is a process through which a certain ontology manifests to an observer. It is the means through which we attribute a certain ontology to a certain object. Therefore, since we have seen that the framework introduced by Heisenberg can be seen as a process, an instrument for a process of intentional constitution, we can claim at this point that it actually has a definite ontological meaning. It defines the electron's ontology in the phenomenological sense that it defines what empirical manifestations can be traced back to the electron, what are the regularities that define the electron, which are the regularities that can be captured by this kind of formalism, and what are the structures of experience associated with its manifestation, which are, as we have seen, relativity, horizontality, and so on and so forth. I didn't prove in the details that this style of manifestation can be recognized also in the case of the Heisenberg's atomic electron, but it is possible to do that in a quite straightforward way. So, in the end, my aim was to obtain a twofold goal. The first one is that we have seen that the operation carried on by Heisenberg can be interpreted in an ontological way. The second, we got some information about the peculiar way in which entities like elementary particles in general manifest in scientific practice in a way that can be interpreted as analog to a process of intentional constitution. Namely, we have noticed that in that case, the mathematical formalism plays a fundamental cognitive role. So I think that these results show quite well the potential, the largely unexplored potential of phenomenology in the inquiry about the ontology of quantum entities. And that's all. Thank you very much.
From this side, I'm giving this to, the first profile was that.
Okay, so a short question, but thanks very much. It's very, very interesting. But you see, of course, in the case of Heisenberg, he later on in the 50s at least, he introduced this ontology in terms of like Argentinian potentialities and how talk a little bit about that tomorrow in actually the case of David Bohm, Heisenberg. But that, of course, really is quite different from a more phenomenological approach. So, how much theories are you putting, you like, phenomenology to Heisenberg that perhaps didn't really think about the things in this way?
Yes. No, this is a very important clarification, and thank you for this question. Because what I'm claiming here is not that Heisenberg had any kind of phenomenological perspective on atomic physics, on what the reaction was, and that he didn't mean probably to introduce any kind of ontology. He quite clearly declares, for example, in the Kuhn's interview, that his idea was to reduce the theory to observable quantities alone, renouncing to all ontologies, in particular to ontologies characterized by classical or semi-classical elements like those implied in the Bohr-Sommerfeld model. What I'm claiming here is simply that we can interpret this approach a posteriori, let's say, as a process that can be seen through this kind of phenomenological lens. But I'm not attributing to Heisenberg at all any kind of phenomenological insight. So the idea was to show that phenomenology offers us interesting conceptual tools to deal with problems associated with the ontology of quantum entities, in particular the ontology of elementary particles in this case.
Okay, I'm always wondering about the phenomenology here, because there is a basic problem in phenomenology which we would address. The point is that, as I understand, phenomenology in Husserl's sense, it's about subjective experiences.
Yes.
Yeah, and what you are doing here is you're talking about them, and you're using words and using numbers and equations and things like that. And these are intersubjective objects. And so, in one sense, what you say could just as well be acceptable by any empiricist talking about the external objects. But the point, the problem, if you will do something more, do some phenomenology, you need to address the question about the directness in the intentionality. The problem is that if you have any intentional state is directed to an object, and this relation you need to address. And this is particularly problematic here because in order to do physics or do science, you need to be able to identify one term with another expression for the same object. And this is the problem here. So in one sense, I have no difficulties to accept what you say as an empiricist. But if you go further and do phenomenology of this, it seems to me to raise more problems than to solve.
Okay. Yes. So I start from the first question. Yeah, for sure, it's true that evidence is first of all about individual perception, a subjective perspective. But what Husserl aims to tackle with his phenomenological approach is the objective way in which, starting from a certain kind of structures of experience, a subject, a generic subject, constitute certain kinds of objects. And I think that this is objective, at least in a Husserlian perspective. He doesn't mean to make a psychology of how the individual subject receive perceptual impressions or like that. He precisely aims to tackle the objective ways through which to certain experiences, to certain structures of experience, certain objects, certain ontology correspond. So for the second question, I'm not completely sure I understood the exact point.
If you want to say, if you want to analyze the intentionality,
Yes.
the intentional relation is the relation between an act and an act object. And that, for example, you could say, I see that something. And if you replace a singular term in the sentence coming after that with another term referring to the same object, it is often, sometimes at least, it is the case that the truth of a sentence changes. Take, for example, say someone, a person says, I know that Kamala Harris lost the election. It might be false to say about her, she knows, it is possible that she doesn't know that Kamala Harris was vice president. If you say, Kamala Harris, the vice president lost the election, she didn't say that, and it is another truth value. The point is that two terms inside the description of the object of the intentional relation cannot be replaced for each other. So here you have, and you need to, in science, in mathematics and physics, you need to be able to always replace one term for another, which refers to the same thing. And this is problematic in phenomenology.
So the problem is basically, if I get it correctly, is basically about the mediation of this symbolic layer represented by mathematics, the mathematical language.
And then you don't need to introduce intentionality.
I have to admit that it's not completely clear what's the problem here.
Okay, we can discuss it.
We may discuss it later.
Yeah.
Right, we have 4 more questions. So the first one is here. Then
Maybe my question is related, I'm not sure. So say that I dream every night that I do an experiment where I see a certain resonance and it is consistent with a certain mass, spin, and charge and so on. And as you know, dreaming is a very thorough hallucination. Very clear, but very thorough. So I certainly feel I am experiencing that and I am a subject of that. Would I need to conclude that there's an ontology, or that experience of that supposed particle exists as some sort of an ontology? I could associate some theory behind it. Would that be a correct conclusion according to your perspective on
Well, no, if I am aware that what I'm doing is dreaming. If I am not aware that I'm dreaming, and this is the sense you intended to mean, I think, yes, I will be in this situation in which I believe to have certain perceptions and so on and so forth. So I unavoidably end up with this kind of problems. But I think that we can use the very same argument against ordinary reality in the very same way. I can just be dreaming to be here giving this talk, and what enables me to tell whether this is reality or this is a dream. So for sure, yes, we have this problem, and I think it's a quite classical problem in general. is the basis of many forms of skepticism, for sure. But for sure, this is not a problem that concerns only scientific experience, but it concerns also ordinary experience. It could be an interesting point to be considered in terms of the similarity between the ordinary constitutive practice and the scientific constitutive practice. But yeah.
All right, we have 5 more minutes and 3 questions.
First of all, again, thank you very much. I appreciate your talk. I was wondering whether group theoretical approaches wouldn't be more effective in putting together the fact that if I move around the table, the object is what is inherent under my motions, and of course particles can be represented in group theoretical way. So why don't you consider group theoretical approaches?
Yes, absolutely. This is a great question, and indeed, this perspective based on the combination of, or better, the application of group theory to phenomenology was indeed pursued, for example, by Patrick Heelan in the 70s and in the 80s. But his approach to the role that mathematics plays is a bit different from mine. I mean, for sure, we can characterize objects, constituted objects that we can consider constituted in a phenomenological sense, from the point of view of the symmetry groups that ultimately define this object. And this perspective, this idea that it is this kind of regularities that can be captured, for example, by a certain group of transformation that define what an object is absolutely compatible with a phenomenological Husserlian approach. Here, nonetheless, I'm not focusing on how it is possible a posteriori to characterize the, let's say, essence, at least in a phenomenological sense, of the object in mathematical terms through groups of symmetries. For example, I was focusing on the role that mathematics has, not a posteriori in the characterization of the object, but in the process through which the object is being constituted. So for sure, also in this case, we could try to formalize this kind of phenomenological approach through the application of group theories. Yes, for sure, that will be very, very interesting, and it is a direction of research I have considered for the future. Yes, definitely.
Thank you, Daniele, for your talk. I had the feeling that what you say about the constitutive role of the Heisenberg approach, might be said on many points in which mathematics is used to connect theory and experience. So even the Born rule satisfies some of the properties that you list there, and then it synthesizes experiences, it helps to give anticipations and so on. And but on the other hand, we would resist to think of the Born rule as a kind of constitution of quantum systems. So what is there of specifically phenomenological in your case about Heisenberg?
So it's for sure true that we can think to apply this framework to many different cases in physics in general, in quantum mechanics in particular. But what this case has very specific is the fact that after Heisenberg introduces his matrices and all the formalism, we are left only with the mathematical structure, with the mathematical formalism, and the observables. So, what differentiates Heisenberg's move, for example, from what has been done before by Bohr, Sommerfeld, and their description of atom and so on, is the fact that before the atom was, yes, characterized in mathematical terms, but always using inferences to the best explanations based on the use of already known ontologies. So, for example, in the Bohr-Sommerfeld case, I have these irregularities which I capture mathematically, but I posit the existence of something which I derived from ordinary experience. I take a small grain of sand and I imagine to shrink it until it gets to the required dimension to represent this hypothetical corpuscular electron. So in the Heisenberg's perspective, we do not have this, and this is what makes this case different from many other cases in which which is basically what we normally do in physics, use mathematics to capture regularity. The fact and what makes this case study relevant for the phenomenological approach is that there it is evident that what we have to put different experimental evidences together is only the mathematical formalism, the naked mathematical formalism plus some interpretations without any contamination of the use of already given ontologies, as it typically happens when I resort to an inference to the best explanation. You know, you take the famous example by Bas van Grassen of the mouse. I hear the noises at night, and I infer that there is a mouse in the house. Yes, I can do that because I already know what a mouse is. I have a concept of the mouse. And that is something analog to what Bohr was doing when hypothesizing that the electron was a corpuscle, basically, which is completely different from what Heisenberg does, precisely because he renounces to these kinds, to all these kinds of inferences. And that's what makes Heisenberg's matrix mechanics case very relevant. Even if, of course, as you say, we can see also other examples of cases in which we have this gathering of different manifestations of objects, phenomena, and like that, gathered throughout the use of mathematical formalism.
All right. Unfortunately, we reached the end. Sorry, we have one question left, but it's lunchtime, so let's give our speaker first